Welcome back, grade 12s, to my online classroom. I am Mr. Pimbuisa, your instructor for this section or subject. We are still doing climatology. This is session number 7, which is lesson number 3 of the topic mid-latitude cyclones. In this lesson, we'll be looking at an application of all the content we've done in the previous 2 lessons. We are going to be looking at how do you approach answering examination type of questions when it comes to this topic to sort of reinforce some of the content we've covered. You'll remember that, of course, it may be easy to sort of understand how the system works, where it forms, what characterizes it, and what associated weather patterns come with it. And but some of you find it really difficult for you to really respond to examination questions, and also think about how you want to put the responses in your examination. So we are going to be looking at some of the geographical skills and expectations that the examiners may have for you in your geography, so that you can fully master how you answer questions for this section, so you do really well on this topic in your examinations. Now, the session outline is basically the same as the one of the previous 2 lessons. Now, in this section of work, we'll be looking at an application of all aspects of mid-latitude cyclones, in terms of where they form, what conditions are necessary for them to form, what characteristics are they associated with, the different stages of formation. Remember, you need to be able to identify this on diagrams, synoptic weather maps, satellite images, and so on and so forth. You also need to respond to some questions that may want you to make reference to the associated weather patterns with a cold front, a warm front, and an occluded front. Lastly, you'll have to know the impact these systems will have on humans, the environment, the economy, and strategies that we can put in place to mitigate the negative impact or reduce the negative impact these systems may have. Now, without wasting so much time, let us get to the first question. Now, the first question is as follows. This is sourced from the DBE February March 2017 question paper. Now, we have in our diagram here figure 1.3, which is showing us a mid-latitude cyclone over the USA. Now, let me ask, where is the USA? The USA is where? In the northern hemisphere. So that is telling us something about the location of the system and the general shape of the system. Remember, we've covered that in lesson number 2. Now, just to read a short description, of course, it says there, figure 1.3 is a 3-dimensional representation of what? A mid-latitude cyclones over the United States of America. Now, the first question says, name fronts A and B. Now, if we were to study our diagram, we see that front A has the symbols, the triangle symbols here. And we know that the front that has the triangle symbols is what? It is the cold front. So if you are responding, just clearly, distinctly show your responses to say front A is a cold front. And front B has your semicircle symbols, so that is your warm front over there. So you get your full marks. Now, I hope we are fine with that. And we notice that at front B, we have some clouds over there. thick dense clouds and some rainfall over there. And we know that at fund A we have a bit of scattered clouds, but we still do have some clouds over there again. So let's remember that. It means we may be asked some questions on that. Now let us move on to the next question. Question 1.3.2 says, in what stage of development is this mid-latitude cyclone? What stage of development? We know that it is the mature stage. Why is it the mature stage? Because we have fronts, both fronts being fully developed. We have a cold front and a warm front. We have a cold sector and a warm sector being fully developed, and we have a low pressure being developed as well at the center of the system. So that is the mature stage. So in the mature stage, the fronts are fully developed. Moving on to the next question. It says, give evidence. Give evidence. Where? The evidence is in the diagram, which means you answer based on what you see on the diagram, to prove that this mid-latitude cyclone occurs where? In the northern hemisphere. So one piece of evidence from the diagram is what? It is the anti-clockwise circulation of air. Remember, a low pressure system will circulate in an anti-clockwise direction in the northern hemisphere. And another piece of evidence from the diagram is that you were told in the diagram that this is happening in the USA, and we know that USA is in the northern hemisphere. And another thing is that the warm sector is on the south side, so the warm sector is below, and the cold sector is on the north side of the front. And why is that the case? If I were to draw the northern hemisphere, remember, this will be your 30-degree line, and this will be your 60-degree lines. Remember, the cold sector gets to be at the top because your polar A is at the top, right? So your cold sector will be somewhere there, up there. And you remember, your warm sector is below or in the southern side, simply because your warm westerly winds will be in the southern side. So those are the reasons you give. So you give evidence from the diagram on the stuff. So we've explained that in the previous lesson. So I hope we can see how the content and that we've covered actually applies in you answering the exam questions. So remember, in geography, we can't teach you something else and ask you something totally different in the exam. We'll ask you what we have taught you. Now, looking at the next question, it says, give a reason why fund B is associated with greater rainfall extent than fund A. Remember, we said fund B is the warm front and fund A is the cold front. And behind the cold front, there is the cold sector. Behind the warm front, there is the warm sector. Remember, the warm sector is formed with the warm sector is formed by warm air. And remember now, fund B is the warm front, and warm front has nimbostratus clouds. And remember, nimbostratus clouds are not vertical clouds, but they are horizontal clouds, so they have a greater horizontal extent, and therefore they will affect a wider region as compared to the clouds you'd find at A. And remember, the warm front causes warm air to rise very slowly, so this will result in rainfall over a long period of time. And we also think about the gradient of the warm front. We said it has a gentle pressure gradient, and therefore we are going to have the formation of nimbostratus clouds. Remember, in the cold front, you'll have cumulonimbus clouds, and we say they are towering cumulonimbus clouds, so they have a vertical pressure gradient that is steep, so they cover smaller regions. as a result. So while with the warm front, we have air rising slowly, resulting in rainfall over a long period of time, as we have shown the reasons there. So the question here wanted you to think about the structural differences of the different fronts and how they affect the extent of rainfall the different fronts will be able to provide or furnish us with. Next question wants us to think about a description of the likely weather conditions associated with cloud types found in Fund A. I think the first step will be to identify the cloud type you'll find at A. So at A, you'll find cumulonimbus clouds, and cumulonimbus clouds are associated with heavy rainfall. Why? Because cold air will sink rapidly in the cold front, leading to an upsurge of rising air that will cool down speedily, leading to the formation of cumulonimbus clouds, or rather towering to cumulonimbus clouds that are going to cause thunderstorms and also cause very strong winds. And we are going to have lightning forming due to the interaction of different parts of the clouds or different clouds. Remember, you may have your cumulus clouds and cumulonimbus clouds over there, and altostratus and all of that in the warm sector. And remember, there is a possible formation of hail due to strong updrafts and downdrafts carrying water droplets to areas below freezing point. So hail forms because of, remember, updrafts is basically the rapid rising of air, and this may lead to this water vapor to move from a gaseous state straight to a solid state, and so it basically sublimes. So sublimation will happen, and we are going to have hail forming as a result. So those are the possible reasons you may give for that question. So I hope we are fine with this section. We can look at the last question. So the last question says, discuss two expected weather changes that could occur when a mid-latitude cyclone reaches the occlusion stage. So we said here we are in the mature stage. So what will happen in the occlusion stage? Now, in the occlusion stage, air temperature on the ground will drop. Why? Because cold air will occupy the surface while warm air will be in the upper atmosphere, and the air pressure will increase. Remember why? Because we have low temperatures. So when we have low temperatures, pressure will be high, and the wind speeds will decrease simply because we have more sinking air, so we have less winds as a result, and humidity will also decrease because we have cold air occupying the surface, and remember, cold air is mostly dry. Again, we are going to have unstable weather conditions, and what will the unstable weather conditions do? They will stop. And why do they stop? Because we have cold air. Remember, cold air is associated with stable weather, so rainfall will stop as a result. So those are some of the expected changes with the occlusion stage. We can say the cold front occlusion stage. So those are some of the changes that we'll expect. Remember, we've covered that again in lesson number 2. So with all in lesson number 1. So remember, guys, in answering the questions, we still apply our golden rules in how we choose to think about the work. So make sure that you have watched the revision videos, part 1 to 4. So you are able to understand this topic, and also have watched lesson 1 and 2 before you check out the application section of work. for this particular section. Okay, so I hope we are fine with that. Let us look at the next question. Now, the next question is a synoptic weather map based question. So it says, study the accompanying synoptic weather map and answer the questions that follow. So this is the synoptic weather map. I hope you guys can see it. So this has been sourced from the Gauteng Department of Education SIB material from 2013. So of course this is still relevant. So we have to study the diagram before we look at the questions, of course. Now if you look at the diagram, we have your isobars and all of that, but what we are more interested in is your mid-latitude cyclone, because that's the topic we are doing. So we have a lot of mid-latitude cyclones. There is one here, another there, another there. So that's what we have. And they may ask, why are they following each other like that? Remember, they occur in families. Again, if you look at the date there, we have 6 August 2007. Remember, in August it's still winter, so it's in the winter season. So that's also this what is being depicted here. Now let us look at some of the questions. First one, suggest the season, giving 2 reasons for your answer. Now the season there is winter. Why is it winter? Because of the date. The date is 2007 August 6, and that is in winter in the southern hemisphere. And again, the cold front is far north, so the cold front is closer to the interior, which means the ITCZ is not in the southern hemisphere. And your high pressure cells are also further north, which means they are not blocking mid-latitude cyclones from affecting the interior. So these are some of the visible reasons for that. So they said give 2, we gave 3. Now next one, estimate the pressure over Cape Town. So if we look at Cape Town, we have to think about then your isobars, right? We have to think about the isobars. So this is one. This is one 1008, 1006, and all of that. Now, if you were to look at your isobaric patterns, I noticed that the diagram is not fully visible for you guys, but it's fine. It's fine. So if you look at that, you'll expect that the pressure will be slightly higher in Cape Town, because Cape Town is somewhere here. And why is it higher? Because a cold front is approaching. So we know that when a cold front approaches, our pressure is high. So it means it is above 1000 hectopascals. So that's why you have the answer there being 1010 millibars or hectopascals, because the cold front is approaching there. So that's the main reason for that. The next question, describe the wind over Cape Town. The wind over Cape Town, and give a full account for explanation. Now the wind over Cape Town is northwesterly winds, or you can just say we have up to 15 knot winds. And why is that the case? Due to the clockwise rotation of air around the low pressure, or you can just talk about geostrophic winds. Geostrophic winds are intensely strong winds. So that's the reasoning behind that. And again, they ask, how will the weather over Cape Town change in the next 12 hours? Now, how will it change? Now remember, we look at different aspects. We look at how the temperature will change. We see that a cold front is approaching, so it means the temperature will decrease. And what will happen to the pressure? It will increase, because the two are always opposite to each other. And the wind direction, it will be backing, so we'll have southwesterly winds, and the wind speed will be gale force winds, so they are above 15 knots. The cloud cover is overcast, or we'll have cumulonimbus clouds. Precipitation will be thunderstorms, and we'll have snow in slopey regions or mountainous regions. So those are the conditions we will have. And 1.2.5, to the west of South Africa, a series of cold fronts. What do we call a series of frontal depressions? Remember, frontal depression is an alternative name of a mid-latitude cyclone. So remember, we call these families, and we had already established that they will ask us this question when we were studying the diagram, right, or the synoptic map. So we see that they are occurring subsequent to each other, and it means they occur in families. Now, let us just then summarize, or rather look at tips to master this section. So in conclusion, for you to master this section, now the first thing is that last year, which is in 2021, we conducted a revision series. Please go and watch our video on mid-latitude cyclones. I will attach the link to the about section so that you go and watch that video and look at different kinds of questions, all possible questions, in fact, that you may get from your examiners on mid-latitude cyclones. So you need to expose yourself to different kinds of questions for this section, because remember, geography is a science and we practice in science. So practice how to think about the work, because we did not cover everything entirely on this section, but that video does cover everything as per your examination guidelines, of course. Now please do more practice questions, do article-based questions, or abstract-based questions, more diagram-based questions, multiple choice and concept questions on this topic, and questions that want you to answer questions based on a satellite image. So to master the section, do yourself that favor, expose yourself to different kinds of examination questions. So this was a relatively short class, as we were just looking at how do you apply some of the work over there. So please do go and watch that video for your own benefit. It was posted last year on the revision series. The link is found in the bio or in the about section of this video. Coming up in our online classroom is session number 8, which will be the first lesson on tropical cyclones. Before you move on to the next section, please do visit our website. We are going to post some more practice question papers under the school program. Please do go through some of those questions for your own benefit. I've also posted slides or the content slides from these videos. So please do check them out and use them for personal development on this topic, mid-latitude cyclones. I am going to be doing the next lesson or the next topic with you guys. It will be tropical cyclones. Thank you very much for tuning in to our session. Meet us next time in the next lesson, which will be on tropical cyclones, lesson number 1. I am Mr. Pimbuisa. I'm happy to have you guys in my online classroom. I hope the lessons are of benefit for you guys. Please feel free to share them with your friends. Like, subscribe, and help as many grade 12s as possible to be part of my online classroom. Thank you very much for listening. Bye.
Audio Jungle.